Zoom ones you record, is it?
Sir? Huh?
Zoom ones you record then on your system.
Sir, your voice. I didn't understand.
You can hear me?
Yes, sir. It broke in the middle. Can you repeat?
Let me see if I'm. Is this angle better now or how is it
Yeah,
now?
it's fine, sir. It's fine.
Okay, all right. So the Zoom sessions you end up recording, is it on your system?
No, I don't record them, sir.
Seriously? Your other
No,
classes do not record?
no, sir. I didn't record them.
You.
I write notes. Sir.
Huh?
I write notes in class.
Oh, here you don't write any notes, I suppose then.
No.
Why?
Sir, I don't. I mean, it feels better listening. I mean,
That doesn't sound good to me. But still.
I write sometimes, but not
I
too
understand.
regularly.
Okay, fair enough. However, it works for you, obviously. Let me share the thing. I'll have to open the open book. Send me your papers, of course.
I sent two of them. 1 second.
Center. Let me have a look now then. How much does she nag you?
Sir?
Himatej's assistant, how much does she nag you?
Oh, she just messaged me. Did the class start?
No. The question was basically how much does she nag you?
Uh,
Enough or not enough?
enough. Kind of. Yeah.
Okay. If it was not enough, I would have definitely have asked Himatej to basically make it enough. Because at this stage here, you need somebody to basically place a knife at your throat regularly. Or at least irritate you enough that you recognize that other people will place the knife properly. Okay, so this was the set.
Yes, sir, I sent them.
And the third also. Let's start off with which one? You tell me. Paper 1 or paper 2? Paper 36.
Yes,
So
sir.
that's a tough paper.
Sir?
Paper 1 was a tougher paper, correct?
Yeah. In my opinion, both were just, like equally good.
Equally easy only, is it?
Easy meaning.
Let's see a physics question. Actually, we'll come to physics questions. We'll come to them. I'm hoping I'll get time for them today. So, yeah. Don't feel weird if you have to eat your food in front of me. I don't really care.
Yeah, yes, I don't know.
No, I'm not kidding. I'm very honest there. I really have no problems. Tell me question numbers.
So, you said physics or chemistry?
This is chemistry. I'm not going to talk about your physics before we finish chemistry, bro. Let's finish chemistry. Then we will talk about your issues with physics a little bit, if we have time. If not today, we'll see. I'm guessing now that phase exam is done, new phase is starting. Which topic is your next in chemistry?
Organic chemistry.
Fun. Cool. Perfect. That's fun. Cool. Perfect. So let's start off with this. That means organic is starting now. There's a good bit of time till I'll have to start pitching it. Because initial bunch is like details. I'll obviously be giving you a few details also here and there, adding in a bit of things over here, a bit of pieces over here and there. But yeah, more or less, our organic chemistry discussions will really start only in like maybe after like 3 or 4 full 2-3 hour classes. If you had like 2 hour classes in your, because initially it'll be nomenclature for you. There's nothing to discuss there.
No, yeah.
Realistically speaking, you're a sharp enough kid. I'm not going to demean your intelligence and insult you by sitting and redoing nomenclature. We'll discuss some nomenclature, certainly some weird shit, but only the weird shit.
Yeah, yes.
I will keep my conversations limited there, basically. And I can see that your teacher is competent enough. So, sir will anyway be discussing a bunch of weird shit in class.
Yeah.
So most of my work will already be completed there. So I don't need to really go into the. I'll have to maybe give out like 1 or 2 extra weird shit. That's all.
Yeah.
So more or less that will complete the picture is what I'm thinking. So organic after your sir is finished, like with at least 3 classes, at least 6 to 8 hours of discussion. Then we will have some real meat to start discussing.
Okay, sir.
Then we will only be having like small side chunks.
Yeah.
I will be harassing you with paper more because performance is a little weird. I'm disappointed with your max score. What the fuck happened there actually?
So I made many mistakes, like small, like in the exam. I didn't
Understand
even.
that when you say mistake to me, that doesn't say shit anyway. I know you made mistakes. You got
Yeah.
76, you obviously made mistakes. You're a kid who aims for 100 in that subject, you obviously made mistakes. The question is not mistakes. The question is micro-analyzing each individual mistake as to why it has happened. And the way you are looking at me tells me you have not done that yet.
No, sir. I did.
I will be asking you exactly.
Yeah.
And you know, I won't be asking basic questions. I'll be poking properly.
Yes, sir.
So we'll get to that. So let's start off with which questions here. This is paper one, which I'm having right now. Tell me which question numbers.
So the first question.
First,
Yes, sir.
first,
Sir.
okay. Yeah, okay, okay. First one, next.
And then, sir, the 25th question.
25. Okay.
Then, 33rd question.
Mhm.
34th question. Yeah, that's it. Oh, 40th question as well. Yeah, last question.
Okay, it's okay. You messed up a lot of chemical equilibrium.
Yeah. Yes.
I mean, I'm just basically vaguely looking at it.
Mhm.
And 40 Adam?
Yes, sir.
Ah, fuck. This I would have discussed. If I had touched buffers, I would have discussed this. You'd have 100% gotten this. This is a cheap question which is usually asked in stupid little AITS papers regularly. Fidgy AITS papers. That's like directly lifted from that and this. I'm very sorry. If we had had one discussion on that, we would have definitely touched upon that type of crap. That's pissing
Okay.
off. Okay. All right. Let's have
Sir,
a
your
look.
screen share isn't visible.
Sorry?
Your screen share is not visible.
My?
Screen share. You
Yeah,
can't
yeah.
see.
I was not. You can see my screen
Oh,
now, no?
no, sir, I can't see.
Oh, I have not shared my screen at all yet. Huh?
Yeah, that's
Oh,
what I'm
fuck
saying.
yeah. I've not shared screen. Sorry. I didn't realize that at all. I assumed I had shared. Yeah, sorry.
Hmm. Yeah, no, it's visible.
Yeah, I'm off my game. All right, fair enough. So let's. So these 5 questions, correct?
Yes, sir.
Go for the next paper. Tell me which questions. I want to do all the questions in one shot.
Okay. Second.
The paper. Oh, your mother is there. Okay.
1 second.
Yeah,
I'll
please.
just close it.
Your dinner is ready now. Go get it.
No, sir, it's not there. 1 second.
You're already done. You ready?
Oh, yes, sir. Yeah, I just closed the door. Okay.
Okay. All right. Yeah. Tell me. Second paper. Paper 2.
1 second. So this paragraph 1.
1 second. I'll just get to that. 1 second. 1 second. Okay.
Sir, actually, I don't have any doubts in this paper. I mean, I got them all.
I want to know what you screwed up on.
Oh, okay. Then,
I mean, yeah, you have doubts. I have no problem with your doubts, but I also want to know what you screwed up on.
yes, sir.
What is your biggest problem? You tell me. We have been
Assumption.
facing your issue for a while now. Your issues in chemistry for a while now. You are a very sharp kid. You don't have that many issues, but you have like hidden issues. So, what is your true issue?
Assumption.
Correct. So, those assumptions here, these are the discussions where I will be able to have. This is like an autopsy, which is like a self autopsy, which you have done. Now I will come in and I will be able to see this self autopsy with a different lens on it. So I might be able to see some of your hidden assumptions here. So if I want to be having a chance of seeing your hidden assumptions, I need data on where you screwed up. And yeah, the question paper also. That's why it's very comfortable. I'll obviously be having a look at the questions also as I'm scanning through. when what to say, if it seems interesting, I will know. Obviously, it's not that complicated for me. I'm quite certain what to say. Most of these questions look cheap only. There's nothing complicated over here. I can quite clearly see that. And some nonsense nomenclature issues are there, but that's not a problem. Solubility order, that's screwed up, but it's not that painful. They're not that stupid over there. So yeah.
So
Now,
22nd question.
22nd, Ada?
Yes.
Okay. So theoretical is still your weakness.
No,
Okay.
I don't know what I was
Made a
thinking.
mistake in that.
Yeah.
So
I
your
mean,
assumption was already problematic there. We will see. We'll see. I'm quite sure you have already realized what your issue was. This is a
Yes,
easy
yes.
paper,
Yeah, I
but
did.
still. Next.
And then so this paragraph one. Yeah. Both questions.
Okay. So stoichiometry is weak.
Well, I mean,
Is that a correct assumption?
I think my stoichiometry is fine only, but then I was getting different values in the
Did you
exam.
mistake in the stoichiometry here or not?
Sir?
Okay, we'll see. We'll get to the question next. Well, what else?
And then 35th question.
Paragraph 2, you got fully correct.
Yes, sir.
24, you got correct.
Yes, sir.
Good. Okay, next.
35th question.
Thermo is not done, na?
But then they gave us a formula like minus.
Don't worry, then that's cheap shit. Don't even give a crap about that. That's very badly done. Then that's not the way you should learn shit. So yeah, I'm okay with you making mistake in 35. That's unfair to put a question like that here. Next, what else?
That's it. That's it, sir.
That's it.
Yep.
All right, and the other paper.
Oh, 1 second. So the 51st question.
Next.
And then 57th question.
Okay, one more. Arey, yaar, you made a mistake in this.
Yes. Sir, I put the correct option and then I changed it for some reason. I don't know what I was thinking.
Yeah. Do you know how they cut ice in industry?
No.
Yes.
Pressure.
Huh?
Do
you know how they cut ice? Large, huge blocks of ice in large scale industry. What are the question? One more question should be an error.
Yeah. 1 second. Which question was this?
It will be a numerical.
Yes, sir. This one. 1 second.
Which one?
Just a second. This point. Yes, sir. This 72nd question. Yeah.
72.
Yeah.
All right. So that closes the overall all three papers, right?
Yes, sir.
So have you figured out what you did in this one? Let me quickly read the question. In the given figure bulb, okay, contains an excess of volatile solid. Oh, fantastic. Fantastic, fellows. Finally, I thought you said there was no solid equilibrium which was discussed. Heterogeneous equilibrium discussed for you.
So,
In your school. This is heterogeneous equilibrium, no?
yeah.
Very nice. Okay. All right. Volatile solid A. Aquatic is equilibrium formed as shown below. Okay. So we are having A solid is in an equilibrium with
A gas plus
gas plus A dash gas. plus H2S gas. Okay, all right. At equilibrium, total pressure inside the bulb is 10 millimeters, whereas partial pressure of H2S inside bulb is 4 millimeters. If some A gas is removed from bulb at equilibrium. Okay. This is not that complicated of a question, man.
Sir, I didn't like this decomposition. I thought it
It's
was
not
right, but
decomp, really. Don't call it decomp. They screwed up here.
yeah,
These two
that's what I didn't understand what they're doing.
is independent shit. They fucked
Yes,
up.
it's not even. It's like spectator.
Yeah, it's
Spectator.
exactly. This is crap. This is a very shitty question here.
That's what I was thinking, but then it was multiple correct, so that's why I put.
I'm sorry, it's a very bad question. It's not a good question. I really thought it was a good heterogeneous equilibrium question the moment I saw it, but it's a shitty bad question. The only thing here is A solid is in equilibrium with A gas.
Oh,
The remaining is not in equilibrium and shit. So this is independent gases. So the only part of equilibrium is this. So the equilibrium is actually A solid is in equilibrium with A gas. This is the equilibrium. That's it. Nothing else. So if A gas is removed, a little bit more of it is removed from the bulb at equilibrium. As long as A solid is present, more of A gas will be produced.
yeah.
As simple as that. Nothing else. It's a very bullshit question. I'm very disappointed by the quality of question. I mean, I thought it was better, but it is a bad question. Will that solve your question here completely?
Yes, sir. I was confused about the decomposition part.
It's
There's
not
no decomposition
It's not
happening.
decomposing. It's not decomposing. It is not decomposing. I will give you a couple of questions. If you really want some really good heterogeneous questions to crack your brain on, we'll discuss them. They are fun. Trust me, they are
Yeah,
fun. For
sure.
somebody like you, you'll have fun with them. So you will not find them at your regular exams over here. It'll probably be something where you will, what to say, experience them only in good papers. So we will discuss them. We'll find some time out for that. That's not a problem. Remind me if I forget about it today. Remind me in the next session, definitely. As I said, organic both we'll have time. Organic, there's going to be at least like reasonable chunk of time available now where we can discuss and catch up with some of the older bits, like polish off some of the older stuff and close it off. So we definitely can work on some heterogeneous equilibria questions. This is a very shitty one. I'm very sorry. This is just a crappy question. So A solid is in equilibrium with A gas. So all you have to do is make sure that if A gas is removed, this will move in forward. As long as solid is present, it will move. So decomposition equilibria will shift forward. Yeah, fine. If you want to call it decomposition, yes, it will shift forward.
It was given wrong, sir.
Huh?
That option was given wrong.
Oh, they're not calling it decomposition then.
I also put that, but then
even in the options, they have made shitty things then.
That's what I was wondering. I was like, what is this?
Even the question is bad, the options are even worse. Okay, all right.
Yeah.
So if you want to call it decomposition, see, sublimation equilibrium or shift forward is obviously correct.
Definitely, yeah. And
But
the
the
pressure
fact
is also stays same. Yes.
But the fact is this. If I'm going to be having a piece of my hand vaporizing, will I call my hand decomposing or not?
No. I mean,
No.
maybe.
Yes, technically my hand is getting destroyed, right?
Yeah.
What did Thanos do in that shit?
Yeah.
So if let's say somebody lost half their body in that crappy movie, somehow survived.
Yeah, decompose their body. Yeah.
Yes, correct. We'll be using that terminology there, correct?
Yes, sir. Yeah.
So why should we not use it over here?
Yeah, that's what I was thinking in the exam. So like,
I'm not arguing against your pointer. I'm arguing with your pointer. I'm trying
Yes,
to.
sir.
This is a shitty question. So
Yeah,
don't give a crap about this question. Sometimes teachers make questions just for the sake of getting wrong answers out of students.
Yeah.
Because it's a controversial one. And they know it is made that way so that it will give those answers. It's not something which I'm not played. I agree that it has to be played because any teacher who is worth their salt has to use these kind of tricks once in a while. Because a teacher's grade officially in the eyes of the management in any system, unfortunately, goes up if more students fuck up on their papers. And if they're able to sell the question to other teachers also, that this is an acceptable question. You understand what I'm saying? Because teachers will not keep quiet. If there's a paper made by some other teacher, your teacher will go and argue.
Yeah. Yes, sir.
It got so irritating for me that my question papers used to have so much nonsense. I mean, I also used to play this game. Shamelessly, I'll say this. And I'm far worse than these guys. If I have to get into it, I can be far worse. I used to have like, I had to spend like 3x the amount of time fighting with faculty after the exam. When I say X, 3x, I mean X was the amount of time I had to sit preparing the paper and preparing the questions, proofreading everything. 3x was the argument. I used to get fed up with it. And towards the end, I was like, fuck it, I'm purposely going to make sure there's no controversy. Let me score. It's fine. I don't care anymore. When you get questions of this sort, don't feel bad. Not just in chemistry, in physics or maths also. You will find them rarely in maths.
Yeah, in maths it happens.
A little bit more often in physics compared to mathematics, but most often in chemistry.
Yeah.
Don't worry about them. You'll find them a lot more often in inorganic and in organic, but don't care about them. These are all shitty questions which are just there for the sake of inviting trouble. No other purpose.
Yeah.
Don't worry. If it's not that JEE will not give them. Learn how to attempt these. What should you learn here? You should learn how to not lose marks here. This was a more than one answer correct question is what you said, correct?
Yes, sir. Yeah. No negative marking.
Negative marking or no negative marking?
No negative marking paper on.
Good choice then. The
No
fact that you
partial
attempted
marking.
with it is not the wrong option here. But the fact of the matter here is this. You did one shitty thing here. What was the shitty thing you did here?
Ascendus decompose. I mean, it is.
I am not questioning the fact that you attempted it. I'm going to guess what you did over here. I don't even know what you have marked as the answer. I'm going to guess. I'm guessing you got 0 here in this question instead of scoring partial positive.
No, there is no partial marks.
Oh,
Yeah, that's why I can
fantastic.
do
That means my assumptions were wrong over here. So effectively in this year, what you did was right move here.
all or nothing.
Bad
Yeah.
move at all. It was the correct move. You went with your gut over here. And since there is no partial marking, it is partial mark. It's no marks or full marks. Huh?
No marks.
Repeat again. It's no marks or
It's
full marks.
3-0.
Right?
Sir?
It's either full marks or no marks.
Yes, that's it. Yeah.
No negatives, no partial.
Yeah.
You did the right thing here. I agree with what you have done. I'm guessing you went with all the options you saw were possible.
Yes, sir.
And you
Yeah.
went with it. It was 50-50 choice, man. There's no other option you
That's
can do.
right,
Yes.
yeah.
What are you supposed to do here? Nothing else.
Okay.
Good choice. Well done. Let's move on. No other problems in this question now?
No, sir.
Okay, this is a shitty question. Let's go to 25. 0.2 moles of Na2S, 0.1 moles of H2S, 0.1. Okay, this is a fantastic looking question.
I was
Let's
very confused about
What
this.
is happening over here? Is it really a fantastic looking question or is it just a shitty question?
It took
So
me a
we
while
have
to-
HCl, we are having sodium sulfide and we are having sodium chloride or dissolved in 1 liter water to make a solution. K1 and K2 are given. The true options is or are concentration of H2S, concentration of sulfide, concentration of HS minus and pH of the solution. This is actually a cheap question, beta. It's a very cheap question. Let me explain what's happening over here. It's a question based on common ion effect.
Yeah, common ion, yes.
Purely a question based on common ion effect. So let's start off with what's happening here. So we are having Na2S. What kind of a substance is this? Strong electrolyte or weak electrolyte?
Strong.
Strong electrolyte, it's a goddamn
Yes.
ionic salt. So it will break off completely to give me 0.4 moles of Na plus and 0.2 moles of sulfide ion.
Yes.
Flat out, that is there. All right.
Yes.
In this
Yeah.
1 liter solution.
Yeah.
That is absolutely there. Next,
Mm,
this HCl is also going to be a strong fellow.
completely dissociates.
So this will also break to give me 0.1 moles of H plus and Cl minus.
Yeah.
Okay. And this fellow is also a strong electrolyte.
It also
So this will
dissociates.
also give me 0.1 moles of Na plus and Cl
Each
minus.
ion.
So if I'm looking at my totals over here in the 1 liter solution, what do I have from all of these strong electrolytes together?
0.5 mole NaOH.
I have Na plus here
Sorry,
and
Na. Sorry, no, yeah.
0.5
moles Na
moles
plus.
of Na plus
0.2 moles H2 minus. 0.1 mole H plus and 0.2 mole Cl minus.
and 0.2 moles of.
Cl minus.
When you've got it like this, the next thing you should do is you should check if the positives are being balanced out by the negatives. Why? It's like a quick check that what you
It's
have
correct.
gotten from the question is not wrong.
Okay.
You understand what I'm saying? There
Yes,
will
yes.
be small
Very
small
fine.
checkpoints whenever you can basically when you're solving questions, you should remember these checkpoints, because in these checkpoints, if you have checked them once, that means your calculations are not going to go wrong up to that point at least.
Yes.
And what to say, you can, if you have checked them once when you're doing the question, when you're checking the question again later, if you have got the benefit of that time, you will remember that you checkpointed over here already.
Yes. Yeah. Okay.
You understand the idea there?
Yes.
So
Sir, yeah.
try to come up. I mean, I think you're already doing that. I'm supposing for mathematics and physics, at least to
Yes.
some extent,
Yeah.
and chemistry also to some extent. Try to incorporate them a little bit more carefully. So 0.5 moles, 0.6, so 0.6 plus, and we're going to be having 0.2 into 2 and 0.2 into 1. So perfect, 0.6 minus. Okay, all right. So what is my last fellow here, which is in equilibrium, or which is the fellow which is a weak electrolyte here, H2S. So H2S is going to be dissociating to give me H plus HS minus. First
Yes.
equilibrium.
And then HS minus.
We are going to be having HS minus in equilibrium with H plus sulfur.
S2 minus.
And we're going to be having Ka1 given as 10 power minus 5. And this guy is given as 10
Minus
power minus 7. Let's start off. So in this case here, the H2S is given as 0.1 at the starting.
Yes.
So this guy is given as 0.1 at the starting, and the H plus is already how much?
It's 0.1.
0.1. So in this particular case here, I'm going to be having how much as the HS minus here? Directly I get HS minus, no?
So initially it'll be 0, right?
Who gives a crap about initially? You think about the interface, it's 10 power minus 5.
Yeah, then you can hit the KC. Sorry,
Product and the reactant. Stop.
Yes,
This is a question on, this is the important key thing when it comes to ionic and chemical equilibrium. Approximations have to be second nature to you. All right.
Yes.
Let's have a look at what's happening here. You are having a reactant and you are having product in equal goddamn quantity. And you are having equilibrium constant as 10 power minus 5. Will this ever move in forward?
No.
No. That means I can assume that this 0.1 and 0.1 are fixed.
Yes.
Straight I can assume.
Wait.
If it's not going to move in forward in an appreciable manner, what's going to happen? There's going to be only a tiny bit of, 0.1 minus some tiny crap and 0.1 plus some tiny crap.
Yes.
Right? I can automatically neglect. Your brain should straight away go there.
Okay. Yeah, correct.
Fair enough? You understand what I'm trying to explain here?
Yes.
So directly what's your HS minus here? Calculate and tell me.
So 10 power minus. Yeah. That one, yes. Sorry.
Right?
Yeah. 10 power minus 5.
Products divided by reactants. Reactant and the product, one of them cancel.
Yes.
So this has to be then straight away. So your brain should straight away go there.
Okay, got it. Yeah.
And the moment you see this is 10 power minus 5, how much should that be? 0.1 minus x. What is that x there? That's 10 power minus 5.
Very small. Still
so 0.1 minus 10 power minus 5 is 0.1
only. Yeah.
0.1 plus 10 power minus 5 is 0.1 only.
0.1. Yeah.
That is the next checkpoint you should check for immediately.
Yes, sir.
Wherever you do an approximation, your brain should immediately do the checkpointing as well. Is the approximation you did correct or not? How do you check it? Once you got the value, you put it in the equation which you're supposed to be having and see if the approximation you did is acceptable.
Yes, got it. Yeah.
You understand the idea here?
Yes,
all of this has to happen like that. You see, you should know straight.
Okay.
You understand the point here?
Yes.
Let's go to the next one here. In this next one, how much is the
10
HS
power minus 5?
Beautiful. How much is the H plus?
0.1.
And how much is the sulfide?
0.2.
0.2. Now, try. Is this matching up or not?
0.2.
Not, no? Something is, it's not balancing, I'm sure.
Yeah, it's not.
Correct?
Yeah.
So if it's not balancing for damn sure here, let's see what could have happened over here. What could have been the problem here? And if there is a problem, where is that problem going to be? You understand what I'm trying to say here? In this case here, what can be an issue over here? Let's quickly see what is the equilibrium over here, which is supposed to be happening. And what's the issue?
minus.
No, don't think like that. 10 power minus 7 should be definitely equal to, in this 0.1 and 0.2 over here, there can't be appreciable change.
Yeah,
If there is some change, this bugger has to be adjusted. Correct?
Correct, yes. Yeah.
So now let's look at what the equilibrium tells us. It's be products by reactants. So it's
Yes.
0.1,
2 into 10 power minus 2. Yeah.
0.1 into 0.2. 0.1 into 0.2. Now how much is that? That's going to
2
be
into 10 power minus 2.
2 into 10 power minus 2 divided by 10 power minus 5.
HS.
So in this case here, this cancelling off is basically making it 10 power minus, see, how much is
10
it?
power 3.
10 power 3.
Which
So
is
there is a
obviously
problem here. That means they are basically saying the
HS
HS
minus
minus here
reacts
is
with something.
something which should be increasing in amounts over here.
Correct. Yeah.
That's what they are trying to indicate over here. Now let us try to see, is it really making sense for the HS minus to increase over here? Because in this particular case here, if it has to be 10 power minus 7, HS minus increasing is something which has to happen. But why is it actually happening over here? If it is happening, why is it happening? Let us try to examine it here. This is working out as a good question effectively. So why is it happening? Let us examine here what is happening here. In this particular case here, we're having Na plus, correct? What kind of a species is that?
Yeah.
When you're having some problem in equilibrium where the approximation is not fitting, that means something in the stoichiometry or something in the assumption you made with what is happening is wrong. So now you go back and question the assumptions. Let's start. So this is what the solution contained, correct?
Yes.
Now, what is Na plus? What type of ion are these?
Spectator ions.
Correct.
Sorry.
Good. So you finally remembered what we've talked about.
Yes. Yeah.
Stop looking at, when I'm discussing a question a little bit more in detail, I will not go with your teacher's way of going about it, because that will not be the most efficient way. I will go my way. So let's start. So Na plus and Cl minus are spectator ions. So what do we do about them? Don't give a shit. Why?
They won't do anything.
Yes, they will not be affecting my pH of the solution. They will not do anything. They don't react at all.
Okay.
What is this guy?
Which?
Sulfide ion.
Oh, S2 minus is, it takes place in
What is it? What type of a substance is it?
Wait. No.
Go
Conjugate
basic.
base. Yes. Conjugate base of
Conjugate
HS minus. HS minus.
So this is going to be HS minus is already a weak acid, right?
So
this conjugate base of weak acid.
Similar
right?
to
So what
strong
do
base.
we do that as? Similar to
Strong base.
jackass.
What?
What is the kV value for this?
Wait. Oh yeah, weak only.
Correct?
Yes.
What's
HS
the
minus.
Hmm?
Oh no, sorry, nothing.
I wrote it as Ka2 of H plus.
K2, yeah, my bad.
So I can of course put it as Ka of HS minus. That is correct.
Yes.
Not wrong. You're correct. Good. What is it? It'll be 10 power minus 7. So what does that make this guy? Is it a strong base or a weak base? What's the kV you just calculated for it?
10 power minus 7.
10 power minus
7.
What is it then? Similar to what?
Neutral.
It's a goddamn weak base. Mathematics.
Oh, sorry.
Which is going to be having kV value of 10 power minus.
Weak base.
Dude,
Sorry.
Really? I sent you notes last week, jackass. Specifically to read through. What's the idea there? The idea is water is your middle guy.
Yes, it's strong. It's weak. Stronger than that.
If it's stronger than water, it is weak base.
Yes.
Or weak acid. If it is weaker than water, then it is extremely weak crap. And for that fellow, the conjugate will become strong. Aman, are you still on?
Hello?
Yeah, can you hear me clearly?
Yes, sir. Sorry.
So the idea here is, let me go back to that previous session then. Let's have a look at that. I don't remember which document that was though. That's the problem. Doesn't look like this. Did this? Was it this discussion, dude?
Before this.
Before this, sir.
Yeah.
Okay,
This
chalo,
was
whatever.
the
It's okay. It doesn't matter. I'll go back to our current discussion. So the idea here is you're going to be having
H.
sulfide over here being similar to a weak base.
Weak base, yes. Yes.
Go back and refresh the shit.
Yeah, I got it. Yeah.
You have to.
Yeah. Yeah.
You're a mathematical fellow. Stop thinking of chemistry as not mathematics. Chemistry is mathematics. It just has to be
Understood.
it's not easy to understand it that way.
Yeah.
You have to question the shit which goes into what they are teaching you. That's difficult, but what to say, when you have somebody who is already looking at it like that, it is easier for you, obviously. So use it properly. Now, coming back to the point here. So this guy is a weak base.
Weak base.
What is H plus?
Strong acid.
So what will this guy do? React with my weak base, no?
Yes.
So what do I have right now? I have 0.2
H plus.
moles of
H.
base sulfide. And what else do I have? I have
0.1 mole
moles
strong
of
acid H plus.
strong acid H plus. Okay, so now let us write the equation between them here. What will it be? Sulfide will act as what?
Base.
Base. It will accept my acid.
Yes.
And it will end up becoming
HS minus.
HS minus bluntly. So how much of sulfide do I have? I have 0.2.
0.2, 0.1, 0.1.
And how much of this guy do I have in the beginning? I have negligible crap.
Yes. Very small. 10 power minus 5.
Minus 5 is negligible. I don't give a
Yes.
shit about that. I can take it as negligible crap. So now
Yes.
I'm going to be having this H plus getting consumed nearly completely.
Yeah.
Why? Because it will predominantly go in forward direction fully,
Yes.
correct?
Yeah.
So let's say this goes in forward nearly fully. Why? Because this equilibrium is having, what is the equilibrium constant here?
Sorry.
1 by
1 by K, which is 10 power minus 7. 10 power 7.
power 7 this is.
That's huge. Yeah.
That's why this is going to be going pretty much in full forward.
Yeah. Makes
Correct?
sense.
So
Yeah.
now let's push this guy in full forward nearly. So this will become how much? This will become
0.1, 0.1.
for sure.
Yeah. 0.1,
This will be tending to 0.
0.
Tends to 0. Don't call it 0.
Yeah. I
It's
understand.
not 0. It tends to 0. So let's take that the amount left over is X. In your brain itself, you should not think of it as, you should think correctly. If you think wrongly in the brain itself, it will translate onto paper. Never ever, assume that the thoughts are not going to get translated. There will be translation errors also from the brain to paper. But if that goes wrong, this will go wrong at some point of time. So you have to definitely keep that in mind. So this will tend to 0, but it will not be 0. So it's going to be X.
Sir, how do we know
This
when
guy-
to approximate and when not to approximate?
Let's go into what is happening. Then you'll understand immediately when to approximate and when not to approximate. In this case here, what is going to be happening? This one, what is the equilibrium constant here? You tell me for this.
10 power 7.
10 power 7, correct? So if it is 10 to the power of 7, what is the basic idea there? It is going fully in forward.
Yeah.
So you blindly go for full forward. But nothing will reach 0. This has to be 10 power 7. Something should make it 10 power 7, correct?
Yes.
What will make it 10 power 7? This H plus ion tending to 0 will make it 10 power 7.
Yes. Denominator being small. Yeah.
You understand the principle there?
Yes.
So that is something which is tending to 0 but non-zero. So you take it as an X.
Okay. Yeah.
The remaining ones, this is why your limits understanding comes into play.
Yeah.
Whenever something is
thinking.
tending to a 0 or an infinity, you should not approximate. You should keep it as a variable. If something is tending to an actual number,
Okay. Like relatively, like we approximate.
Correct,
10 power
correct,
minus
correct,
2. Yeah.
you
Yeah. Got it.
understand the point over here, na? It's
Yes,
all
sir.
about the asymptote on the curve. When
Yes.
you're coming closer to an asymptote on the curve, you should not approximate. Because at
Yeah.
that point, it becomes more important to be exact.
Yes.
When you are
Yeah.
on the actual part of the curve, nobody gives a crap.
Yeah. Pretty negligible. Yes. Okay.
You understand the principle over there, no?
Yes, sir. Got it. Yes.
So, I don't know any other way to look at it. I mean, I look at it from the asymptote point of view, it always works. So, yeah. In this case here, of course, that is mathematics. As I said, you have to bring in math here. If you want to do your approximations properly, math is very critical. Math will help you a lot here. You'll see in this question itself. So here, this guy tends to 0. So it is approximated as x. Will this guy be tending to a number or to 0? HS minus.
To a number.
What will be the number?
0.1 minus x.
Perfect. 0.1. Not minus x.
X will be negligible.
X is negligible. So 0.1.
Compared to 0.1. Sorry, yeah.
0.1.
Yeah, I got it. Yeah.
So in this particular case here, what are we going to be having? We are going to be having sulfide. Let's now write the equilibrium differently now this time, so that we get a more clearer sense of the equilibrium here. So HS minus is going to be in equilibrium with H plus plus sulfide, where my H plus is tending to an X. This is 10 power minus
7.
And this is approximately 0.1. And this is also approximately 0.1.
Correct.
Now, what is my H plus tending towards then? Let's not don't answer that. Don't answer it for now.
Okay.
This is something which I can blindly answer what this X is supposed to be, but don't answer because there's one more equilibrium also at play here. What's the other equilibrium? This first equilibrium will also be affected.
Yes, sir. Yeah.
So let's have a look at that. So what do I have now in the solution? This is a very good question. Honestly, it's a good question. So let's start with this. So my solution contains what now? This again comes to the other question also. We will discuss that also simultaneously with this. These two are similar questions actually.
So, yeah, these two.
Let's quickly analyze what's happening over here. I will give you a test question. Let's discuss this question itself. So 3 moles each of this guy, this guy, this guy, and this guy are mixed together to form a 1 liter solution of 1 liter nonsense. Okay, all right. So let's mark down what is there individually here quickly. This question is something which will be a useful precursor to that one. So we'll quickly touch upon this. This is a much easier question, obviously. So, yeah. So in this particular case here, H3PO4 is going to be 3 moles.
Yes.
Okay. Then we are going to be having H2. I need to write a little bit above now. Okay. Okay. I'll write it on this side. So H3PO4 is going to be 3 moles in the beginning. This Na plus, what am I going to do about it? When I say Na plus, what does my brain tell me? Straight away spectator, don't give a shit.
Yeah.
If I see Cl minus, straight away spectator, I don't care.
Yeah.
You understand the idea here?
Yes.
Remember, when you think of spectator, abandon. Don't care. Straight away, don't care. Your brain should directly go there. Of course, there are key things to watch out for even over there under weird circumstances. For instance, if it is going to be, say, something like a highly concentrated strong electrolyte solution, like say 30 molar sodium chloride or 35 molar sodium hydroxide, 35 molar sodium hydroxide, super saturated type of crap.
Yes.
In that situation, yeah, there is no spectator. You understand the point over there? So in most cases, these guys are all only in those cases. Only in those cases. So from your point of view, you'll never get them. You'll never get those cases unless you go into second round of Olympiad. Till then, you'll never, even then, sometimes you won't see them. So, yeah, you don't need to care.
Okay. Yeah.
From your point of view, you see Na plus, Cl minus, abandon, spectator, go away.
Yeah.
So, don't care. Don't care. Don't care. Let's go with the H2PO4 minus. That is going to be 3.
All right. Yes.
HPO4 minus 2. That is going to be 3. And PO4 minus 3 is 3. Now, I would have discussed this with you at some point of time. Not in this manner, but I have talked about it in some place somewhere. If I'm having, say, 2 acids in my beaker, or I have a beaker here, I'm having 2 acids. All right. One is stronger than the other. If I add base into it, which guy will my base react with first?
The stronger one.
Correct?
Yeah.
You agree with that fully, correct?
Yes, sir.
Why? Equilibrium.
Yeah.
Equilibrium.
Yes.
So as long as there is a reasonable gap between the Ka values, which is quite clearly seen here,
Oh, yeah. Oh, then
quite clearly pointed out over here. What does that tell you if there's a reasonable gap between the Ka values? It tells
Iraq with a
that
higher
one guy is a stronger acid than the other.
significantly. Yes. Yeah.
That is a principle to use over here. Let's blindly use it. So this guy is my strongest acid number 1.
Hmm.
This guy is my strongest base number 1. So first what will happen? Strongest acid will react as the
Strong
acid
base. Strong
base.
base. Yes.
So the strongest acid will go to 0.
Hmm.
Strongest base will also go
Six.
to 0.
No, sorry, 0. What? Yes. Yeah.
Amounts left over.
No, yes. Yeah.
Correct? Let me write the equation because I maybe have overestimated you. So let me put down the equation. H3PO4.
Yeah, I got it.
No, it's okay. Because the real overestimation will come in the next step over here. So this H3PO4 will go to 0 now. This guy will increase by 3.
Yes, 6.
Yeah. And this guy will also increase by 3 when the PO4 3 minus is going to 0.
Yes.
This was the overestimation, but it looks like I have not overestimated you. I'm quite thankful. This fellow will end up becoming H2PO4 minus.
So 2 minus.
6. Now, what do you have? Buffer.
And then, pK plus 8.
No, not pK plus pKb here. This is not that. This guy is acid, this guy is base.
Yes.
Or this guy is base, this guy is acid, whichever way you look at it. Okay, so this is going to be both in equal amounts.
Yes.
So you can do that also here. You have 2 acids, 1 acid and 1 base, both in equal quantity. If I have weak acid and weak base in equal quantity, what can I do?
Then you can use the buffer.
That formula also you can use. Half into pKw plus pK. That also is applicable here. One more trick which you can go with over here is in this is basically nothing over here. You can directly use your standard buffer equations to solve off over here. So it'll effectively be, I think you can solve off from here, yes?
Yes. Now they will do it. Yeah.
So effectively you're going to be having in this case here, pH is equal to, if I take this guy as my acid. So this is Ka2. Correct?
Ka2 plus just Ka2. Yeah.
pKa2 plus log of
1 by 1. 6 by 6. 0.
Acid. Never take it as salt by acid.
Yes, sir. Yeah. Because
conjugate base by weak acid. So this guy is your conjugate base.
6 by 6 1.
6 by 6 1 done. So it's pKa2.
Okay.
You understand the principle here? What's the pH here? 7.
7.
Clear?
Yes, sir. Yeah.
Now we go back to that one. Let's have a look here. What's in my solution? What's in our solution now? What does the solution contain now?
0.2.
No.
No. HS minus. No.
It contains 0.1 moles of. What did we have?
S2 minus.
Sulfide.
Yeah.
And
S2
0.1 moles of HS minus. Correct?
Yeah. Yes.
Now, what do you see? What else is there? There's some sodium plus and some chloride, correct?
Ignore.
Care about them?
You can ignore.
No, we don't care about the sodium and the chloride.
Yes.
So, now, what is this?
Buffer.
Exactly. It is not, is the exact same as that shit, correct?
Yeah, exactly. Yeah.
Is the exact same as that shit?
Yes.
So now you can directly find the pH. What's the pH of this buffer? pKa, if this guy is my weak acid over here, this guy is my conjugate base.
Yeah.
Correct? So it's pKa of HS minus.
HS minus, yes. HS minus was 10 power minus 7.
Plus log of 0.1 by 0.1.
0. Yeah.
0. So implies pH is going to be, what is the pKa of HS minus given here?
10 power minus 7.
10 power minus 7.
7 only is the pH.
So if pH is 7, then what is my H plus?
10 power minus 7.
Done.
So, but then
H plus is 10 power minus 7 here. That means the solution's H plus is 10 power minus 7. But the problem here is this is not correct. Why is this not correct?
You didn't consider the other thing.
What is the other thing which I have not considered here, which I have basically made a mistake on over here?
This thing. H from these two equations, the first two we wrote.
No, this guy. I made a mistake
Yes.
taking shit down and writing here in the first place.
Yes.
My solution is not containing all of this. This is all from strong electrolyte only.
Yeah, and then you have to add this H2S as well.
Yes. When I'm looking for the pH of the buffer and shit there, I have to include the H2S. H2S is 0.1. That means my solution contains over here this entire
0.2. Yes. That's what I was wondering.
Point here. This entire crap is wrong. Why? Because all of this was only strong electrolyte analysis. We didn't touch the H2S. So this was a mistake which happened purely because I had taken down and written separate
only for the
electrolyte.
Yes.
Avoid making this kind of a mistake. I was having enough time. I recognized what was happening. I played it to the way it has to be played. But when you're doing an exam, this is a very big blunder. Writing it as all strong electrolytes. No, that's a very bad classification. What's the best classification? Solution contains.
Yeah.
Put everything. Because if you're taking only a bit of the information from the question and writing it down, this will be a wrong checkpointed information in your brain.
Okay. Yeah.
You're not taking all of the information from the question here.
Yes, sir. Yeah.
So it's a very wrong thing to do when you're attempting a paper. It leads to errors which will happen unconsciously, where you think you have done it correctly. So avoid this kind of taking data out partially as a set. Either you take all the data out and write it down, or you do not do this. Or you keep track of it properly.
Yeah.
I was keeping track, so it was okay.
Yeah.
Keeping track is difficult. Errors will come up. Probability of error will increase. So do not do that. Avoid it. Your job is not to keep track and be smart about it. Your job is to avoid the error in the first place if you can.
Yeah.
Now, so H2S is going to be there as well. So let's continue on. So we're going to be having 0.1 of H2S.
Yes.
Now look at why I basically went to discuss that.
Now these will change.
What's happening here? What is present now?
Again, 0.1.
This is what?
Yes.
Strongest acid.
Yes.
What is this?
Strongest.
Strongest base. So which two will react now?
These two.
So let's now write it down separately. So I'll put it down over here in a fresh manner. So we are having
2 HS minus will come.
And now it is easier to basically proceed on.
Yeah.
H2S is going to be 0.1. So solve off, no problem. Feel free.
Yeah.
So you're going to be having 0.1 of this. And the problem is you made a goddamn mistake there as well. It is not 2 HS minus. 2 HS minus will increase over here. But I think you said come. 2 HS minus will come is what you said. That's wrong. It will become 0.3. This will go to 0. This will go to 0. This will go to 0.3.
No, when I said the react.
Oh, you said increase, na?
Yeah.
Fair enough. I that's why I was not sure what you meant over there. But you said 0.2 will come. I didn't know.
I meant
that it meant come from this or come finally.
Oh yeah. Increase, I meant. Yeah.
So
0.3 at the end, yeah.
0.3 at the ending. So my solution contains what? Final solution contains what?
0.3 moles of this.
HS minus. What is HS minus? Both weak acid and weak base?
Yes.
Right?
Yes.
You have discussed this guy, middle fellow? What's the pH for a middle guy?
The pK1 plus pK2 by 2.
Into? Half.
Yeah, by 2 I said, yeah.
Oh, by 2. Okay, sorry, I didn't listen to that clearly. So what does this come out as now?
6 only. Yeah, 6.
10 power minus 5, 10 power minus 7.
A is correct, B is also correct.
So 10 power minus 6 is equal to pH. I mean, pH is equal to 6. And 10 power minus 6 is H plus concentration.
Concentration, yes.
And what is present in the solution? Only 0.3 of HS minus will be present. Everything else is gone. So let's start off. A is correct. B is gone. But technically we can check.
So B was...
Why is it possible? We have to actually check in the equation now. Substitute it now. So H2S is in equilibrium with H plus plus HS minus, correct? So HS would have tended to 0.3.
Yes.
But the H2S is tending to 0.
Yes.
So I should not approximate.
X. Some X.
Not X over here. X was the H plus there.
What?
So the x plus h plus now we have calculated. This is my x.
Sir, 10 power minus 6 will come. Yes.
So this is x over here, which is 10 power minus 6 calculated now.
Now we
H
can
square
find
row is y, another
10
variable.
power minus 7 kp we have. Sorry,
We
ka we
don't
have.
know h2s. We know ka1 though. This is ka1.
No, k2 right, sir.
This is
One,
k1.
one.
H2
One,
is
one.
k1.
Yes, yes, yes. One.
You're finding
Sorry.
h2s. See, the second
Yes,
option
yes,
is
yes.
h2s, correct?
Yes, sir. Yeah.
So you have to find h2s. So h2s ke
Correct.
liye k1. So 10 power minus 5.
Huh.
So this is 10
Yes.
power minus 5. So now you substitute and check over here. Kya ho raha? So it's going to be 10 power minus 6 into 0.3
0.3.
by
Yes,
y
sir. 3
equal
into 10
to
power minus 2.
5.
Hmm.
So it works out as y is equal to 0.3 into 0.1. So it's going to be 0.0.
3 into 10 power. Yeah. Yeah. That's it.
So is this correct?
Yeah.
Next, sulfide. How do you find this?
Again, same. The second k we have to use.
Beautiful. Good. So effectively, you now take this.
0.3 is already there, and then
HS minus will be in equal with H plus plus sulfide. Which ones do you know now? HS minus tended to 0.3, so done.
H plus also we know 10
was
power
tending
minus
to
6.
0, so we calculated. We
Minus 6 we
calculated
got.
indirectly using ionic equilibrium, using equations. 10 power minus 6, we got that. Sulfide, we do not know. So
Solving we can k when you can use. Yeah.
so this is going to be Z.
Yeah.
We're going to be having equilibrium constant here being given already. How much is that value? 10 power minus 7.
Yes. Yeah.
So solve.
Yeah.
You understand the principle over here?
Yes, sir. Yeah.
So Z
Sir?
into 10 power minus 6 by 0.3 is equal to 10 power minus 7. So 10 power minus
3
1.
into 10 power minus 2.
Z is equal to 3 into 10 power minus 2. In fact, I didn't need to solve for this. Why did we not need to solve for this?
They'll be equal constant.
Why will they be equal?
Because they.
Stoichiometry told us that. Because this guy
Exactly,
tended to 0, this guy tended to the
That's
same
also
0.
yes, exactly. Yeah. Because they both remove the
Principle
same
there,
value.
na?
Yes.
So the logic was both reacted with each other only. So if they both
Yeah.
reacted with each other and they started
Equal
from the same
constant.
place, they should tend to the same value.
Yes. Yes.
So you calculate one, you're done with the other.
Yeah. Okay, makes sense.
So I would not have sat and calculated the C, but I had to show it to you anyway. So I figured why not. HS minus is.
Yeah. So in these questions, it's best to like first list out all the.
No, let me be very honest over here. What you should do for this question. You had 0 or all correct.
Yeah.
This question you should fucking just guess and move the fuck on.
I did that. I guessed 3 of them.
That's the only thing you should do here.
That's what I did. Yeah.
Very sorry. This is a question for people like me. Or for people like you after you have learned the game.
Yeah.
I can solve this in like 2.5 minutes. But I'll have to have proper. I'll have to see this question cleanly enough.
Yes.
I should not underestimate the question in the beginning also. Because if I underestimate it, I will still waste time. This has enough traps in it to make even somebody like me spend like 4 or 5 minutes in it. And of course, it can be done far faster. I'm not denying that. But it will take even someone like me to be as efficient as possible to get it under 2 minutes or 2 minutes less possible. So you should not even feel bad about it. You should just, you see this kind of crap, move the fuck on. I mean, the first time you're saying this, move on. It's not worth wasting 7-10 minutes just thinking and then getting it wrong and then not knowing for sure whether it is. No. This question is given purely to trap you.
Yeah, that's what I did.
Good choice if you have done that. If you have done what you said you did. Not bad.
Yeah.
Good. And yeah, I am assuming you understood what's happened over here, yes?
Yeah. Sir, I put that the S2 minus will be 3 into 10 power minus 2, but then I didn't think that the H2S would also be same.
See, that's the problem there, that is something which you will understand only when you got the. See, in this part here, how would I approach this question here? I'll be very blunt and sincere over here. This is going to be a little bit cheeky over here, but let me say how I will approach this. I'll basically start off with putting down all of the components in the solution there. Straight away, I'll do this kind of crap over that directly. Basically, I did the same thing over here, na?
Yes, sir.
I knew it is 10 power 7, so I directly pushed it into the direction. Here also H2S plus sulfide. Why did we directly add them up and say it is going to go to 0? Check. If I'm writing an equation like this, it's going to be, again, diving a little bit deeper into ionic. But yeah, hell, it's okay.
2h s minus. Yeah, this would also seem
Equilibrium
okay.
constant for this.
Sir?
What will be the equilibrium constant for this reaction?
K K1
Don't
by
guess.
K8.
Don't guess. You've learned how to do equilibriums, right?
Yes,
Adding
sir.
and subtracting equations.
Yeah, K1 by K8. Right?
Do it. Properly do it and get me the exact number. Do it. Is it really K1 by K2?
I think so. 1 second.
Check.
K1. Yeah, K1 by K2. Yeah.
Good. So if it is K1 by K2, what's the value then?
Oh, 10 power minus 2.
10 power minus what? 10 power 2.
10 power 2. 10 power 2. Sorry, 10 power 2. My bad. Yeah.
So how much is that?
That's pretty high. That's high.
Not that high as the 10 power 7. Pay attention. It's not that high as the 10 power 7.
Sir? Huh?
It is not as high as the 10 power 7, correct?
Yes, yes.
So if it is not as high as the 10 power 7, if it is in the order of 10 power 2, then more tricks come up.
Sir, why are you comparing with 10 power 7 though?
Look at the options. I would have read the question if I'm attempting the question in a very serious manner. I would have read the full question and then taken down the data. When I say full question, I mean full question with the options.
Yeah.
All right. So I would have had a reasonable picture as to what is being looked at in the scenario there.
The pH and the concentration.
No, I mean this.
Oh, that's what you mean. Okay.
You understand why I'm pointing there? This I know tends to some number. These two I know will tend to some
those similar numbers.
No, not similar. Some low value because the K1 by K2
that's what I meant. Yeah, similar
that's
to
in the order of 100.
Yes.
So if I know it is going to tend to some low numbers, don't call it similar. We don't know if it's similar or not at the beginning. The similar or not comes only after you have done the analysis
solving
of the solution.
Yes. Yeah, got it. Yeah.
When you're questioning things, when you're questioning your assumptions, you have to seriously look at what you knew if you are trying that out.
Okay.
Actually, when you're how to put it, you have seen boxers doing this shadow boxing shit, right?
Yes, sir. Yeah.
What do you think they imagine? They are actually imagining another enemy who is actually smashing shit at them,
yes,
throwing crap at them, throwing punches at them. That's why sometimes you'll see them weaving in a weird manner when they're doing that shit.
Yes.
And the idea here is when you are plotting your map for the question in your brain, you should remember at each stage what you would have gotten. By the stage when I'm seeing this K1 by K2, I already see that this is K1 by K2, right? I know this is approximately of the order of 100. I know the options are given in that way. So now, when I'm looking at the solving part of what's in the solution, I will try to arrive in such a way that both are approximately coming to a similar number. If they're coming to a similar number and I know this is of the order of 100, then that is approximately perfectly acceptable to be 10 power minus 2.
Yeah.
Samajh raha hai? So I would not, since I know it is 0 or full.
Yeah.
I'm not interested in wasting my time.
Yes. So in the option it's given pH is 6, right? And you can tell by that.
You have to solve. That is the one thing you have to solve.
But like you can tell.
No guessing. That is also guessable. But after you got the full solution done. Solution में तेरा क्या बाकी है? HS minus ही तो only बाकी है ना? Then what's the problem then? Then you don't need to even solve for pH. Who gives a crap about pH? You know how HS minus works. We have talked about HS minus middle fellow.
Yes.
Done then. No problem at all even for solving for that. So if I was solving this, it would not take me that much time. The only parts which will take me time are B and C. You understand? A and D are this. A and D are like this. They'll fall straight. If you understand the solution, how it works, A and D will fall in like half a minute to 1 minute.
Yeah, got it.
The real key issues are B and C.
Yes. Yeah.
You understand the problem there?
Yes, sir.
This is the more than one answer correct question. So if I am in a very tight pinch in terms of solving, time-wise, I suck at math. So I will require more time for mathematics if I was writing the exam. So what I would do is, I would look at what is the rough equilibrium going to be for these two guys. I will not sit and solve. I will see that they are coming to similar numbers or same numbers roughly. I will see to it that they are of the order of 10 power minus 2 somewhere or the other. And then I'll just put it and go on.
Good. Yeah.
If I saw that the number there was 10 power 7,
Go on.
what will be my answer for this question there directly? AD.
No. Huh? Yeah.
If I saw that equation was 10 power 7, I would directly put AD.
Yes.
If I'm seeing it as 10 power 2, or if I saw it as 10 power 3 also, I'll put it as ABCD.
Yeah.
You understand the idea here? This
Yes,
much you can arrive at in 1 minute to 1.5 minutes. Correct?
Yes.
But all of this arriving at is going to be requiring you to already have a clarity of thought as to what's happening. That clarity of thought is very important. If you have that clarity of thought, you can arrive at all of these conclusions in 1 to 1.5 minutes, even for a complicated question like this.
Got it.
And if you still wish to solve it and check it up, it still takes you 1 minute more from there.
Yeah.
That's why I said 2.5 minutes is solvable if I was on A game for this question, which is what you should eventually look at. Because the fact is this, my kid, if you very shamelessly, I'll tell you this. If you want to have a chance at a top 100 rank, you should at least reach my level in terms of solving questions. Or close to it at least. In quite a few topics at least. Sorry.
So can you repeat?
Yeah. If you're really interested in getting into or sneaking into top 100 in IIT, you have to at least reach my level in terms of solving questions. Solving questions, not necessarily theory really, because that is going to require unnecessary junk also being placed in right now. Not worth it. At least in terms of solving questions which are in JE level. This is JE level. Advanced, tough level, but JE level for sure. This is a very good question.
Yeah.
Very well placed question. Answer also easily. You're saying?
It was previous year question, I guess.
I don't know whether it's a previous year or not.
My friend,
maybe. Last 2-3 years I have not seen. No.
Okay.
No. Very much possible in the last 2-3 years. I have not seen the last 2-3 years papers because I have not been in the industry for 2-3 years. Before that, I have not seen this question before. That much I can assure you. So, yeah. It's not that difficult a question, honestly. I'm not.
Yeah.
It can show up in JE Advanced. It'll be a good question in JE Advanced. Not. I've seen much tougher questions in JE Advanced.
In Ionic.
More interesting.
About what?
Huh?
Like, on what topics, sir? Like how are
usually involving
precipitate,
polybasic acids or polybasic stuff only, but involving KSP as well.
That's
everything together. KSP, buffer, acidic, common ion, everything put together. That will be a really, for instance, there is this chapter in JE called qualitative analysis, where salt analysis is done in the laboratory.
Yeah.
In that, a lot of common ion effect and a lot of solubility product comes into play. So in the old JE advanced papers, they used to have subjective questions. They used to give these magically messed up questions, which used to involve so much stoichiometry, so much of salt analysis, so much of understanding inorganic, and you had to weave in ionic equilibrium as well and solve the question. I mean, not basic ionic equilibrium, complicated ionic equilibrium. Like ammonium hydroxide, some buffer is used to maintain pH. Then some sulfide ion concentration is maintained using H2S. Then there is some solubility product kicking in with some metal ion over there. It can be made very interesting. So I would say at a JE level, those are the next stage of questions. Maybe there are, I didn't see any question here. The one you pointed out, none of them were that level. But JE advanced is just like, let's say, there is this level JE advanced. There is this level also above that. That will be a little bit more trickier, where you'll have to really use like mathematical concepts and stoichiometry and understanding truly. Do you have access to books with you for physical chemistry?
Which books, sir?
Which book do you have? You tell me. I will know where they are in those books. If the questions have not changed so much.
For theory?
For problems, not theory.
Sir, Narendra Avastya.
Avasti, you have now. You have the book with you right now?
Yes, sir.
Get it out.
Yeah.
There should be a top class
It's
question.
a older version, sir.
Huh?
It's
Doesn't
an
matter.
older version.
I only remember older version. I have not been in the industry for 3 years at least, 2.5, 3 years. So I don't have the newer version.
Yeah.
I have not seen the newer version at all. So go to the
Level.
ionic equilibrium, the last level. There will be an aluminum hydroxide question as the last question in one of the big topics. One of the most complicated, the last bunch they have, level 2 or whatever. There will be an aluminum hydroxide question.
Sir, more than correct or more than one or single?
Option or whatever, I don't remember. Just
yes. 2 equilibrium, solid equilibriums to Al3 plus
read the
plus
question.
POH minus. Sir?
Read the question quickly.
Sir, the ALOH whole thrice is involved in the following 2 equilibria. ALOH thrice equilibriums to Al3 plus plus POH minus. KSP is
The complexation and the other one are given, right?
The what?
One complexation and one ALOH 4 times -1. That is also given.
Yes. Yeah.
That's a good question. I would say JEE advanced is at this level. This is like slightly above that. So if you are interested, don't look at the solution. The solution is different. There are at least I know at least 2 or 3 ways of solving that. And one of them is their solution, but that is not a good one. That is too mathematical. That is not, it doesn't go down well with the chemistry. I like mathematics certainly, but it doesn't go down well with me. I have a chemistry solution for that as well. So try that out if you really want to get a challenging question. Otherwise, J advanced level is sufficient.
Yeah.
There is enough complexity there itself.
Yeah.
Okay. All right. Let's get to the next one. 2 equilibria simultaneously existing in a vessel. Let me copy this off.
Sir, can I go with my food once?
Please.
Yeah, just a minute. Yeah.
So, you got your dinner?
No, sir.
Kya hua?
They're not at home, sir. They went somewhere. They went somewhere, my parents. I think they went downstairs or something.
You need 5 minutes to go fix it up for yourself?
No, sir. It's fine.
We'll do that. It's not a problem. 5-10 minutes is not an issue.
No, it's fine.
Fix up your food.
It's okay. It's okay.
So food is not ready in Korea, or food is kept and you just need to bring it now?
No, sir. I mean, it's ready, but I need to put on the plate and all.
Yeah, that's what I'm trying to say. It's like
it's fine, sir. I'm not too hungry anyways. I'm not too hungry anyways.
Basically, chalo, you're the kind who will basically, actually, you're like me in that sense. When my parents used to give me food for lunch and shit and all, I used to throw away half of it half the time. So you look like that type only.
Kind of, yeah.
Then this will not be a problem at all. This will be a boon for you. You'll use this as an excuse.
Yeah.
No, fine. No problem. That I can be. 2 equilibria are simultaneously existing in a vessel at 25 degrees Celsius. So 298 Kelvin directly. Okay. This is the next question, right?
Yes, sir.
NO plus NO2 gives N2O3 Kp1 say. Okay. NO2 is in equilibrium. Okay. All right. If initially NO and NO2 present and 3 is 5 molar, total pressure equilibrium is 5.5 atmosphere. This is again a fairly good question from the looks of it. Let's see how the numbers work out. If it works out as a good question, we'll see. You already sorted this out, or you have not sorted it yet?
This one I didn't see, sir.
You have not sorted it out yet?
No, sir. Not this one. Yeah.
Okay. All right. So. That's my daughter's song, actually. It basically goes, here comes the fire truck. Hey, hello. Here comes the Its songs are incredibly catchy, man. Incredibly catchy. So if initially only NO and NO2 are present in a 3:5 mole ratio, so 3:5 mole ratio, okay, and the total pressure at equilibrium is 5.5 atmospheres with the pressure of NO2 at 0.5 atmospheres. Okay, so NO2 is given as 0.5. Mole ratio में दिए गए हैं. Very nice. KP1 is X. Okay, then 10x. All right, this is an actual solid good question. I'll take a fresh page, I suppose. Oh yeah, this is a fresh page. Okay, no, chalo. KP2 is given as 8. Okay. Okay. Pressure of okay, equilibrium. This is 0.5. This is KP. Oh, maybe not that complicated. Okay. All right. So KP2, KP1 is X. X went down. No, let's not call it X. KP1. Okay. I'll be using X as my variable usually, so I don't like to use. Sometimes in the questions they will screw with you basically to see in a question they will make sure that they are using a variable which you commonly use. Either you can make your mind more flexible. Mine is unfortunately older. I'm a little bit more rigid. I'll keep my shitty variables as X itself. I will adjust it at the end. Up to you though. But remember, you should remember what you are doing over there and automatically program it in that manner. Avoid those silly errors. So at equilibrium, this is 0.5. So I'm going to be having in this particular case here, any other information given? Vessel is given. They are not giving me volume of the vessel. Only temperature is available. Volume is not available. Mole ratio is available. Total pressure at equilibrium is given. Off the top of my head, this could be either very complicated or it could be incomplete. One of the two. So it could be a very interesting question or it could be incomplete. So let's start off. Let me start off. So whenever I'm stuck with this kind of a question or whenever I'm stuck with a question of this sort, the first thing is take down the data, read the question fully, take down the data, get everything which you can get out. Unfortunately, unfortunately, that's the first thing which you can do. So let's start off with getting every piece of data which you can get out. So in this particular case here, I don't see any direct path to the answer. So let's get the data. So N2O4 here, how much is that going to come out over here? So at equilibrium, this is KP is 8 over here. So we're going to be having N2O4 by 0.5 squared should be 8. So we're going to be having N2O4 being equal to 8 into 0.25, which means it's going to be 2. So N2O4's partial pressure is 2. So if this guy is 2 and this guy is 0.5, then I'm going to be having what as the total? P total at equilibrium is 5.5.
Already so 2.5 here.
5.5. Out of that 5.5, what are present? I have NO, I have NO2, I have N2O3, and N2O4. Now let me check if N2O3 is given as a liquid or as a gas. They're given all as gases. Okay.
Yes.
So here I have this guy now as 0.5. Done. This guy is now going to be 2. Done. So I have 3 to play with, and those 3 are going to come from NO and N2O3. Okay, so NO was originally 3 moles. This is moles. This is not partial pressure. That and the NO2 was 5. Okay, so now I'm going to assume that a little bit of the forward direction of that equilibrium happens. So let's say this becomes 3 minus X. Let's say this becomes 5 minus X. This ends up becoming X. Okay. So what is my total number of moles of each of these buggers in the system right now?
8 minus X.
This was 5 minus X, but this has gone to 2. Look at this. This has gone to 2 atmospheres here, correct?
Yes.
That means this 5 minus X over here did not decrease by much over there. You understand what I'm trying to tell you here? That is, this 5 minus x is moles left over before the second equilibrium started.
Yeah.
Okay. So for the second equilibrium there, what should have happened is, we should have had the 2NO2. I'm now writing in moles. This is equilibrium. This was atmospheres. Now I'm writing in moles. So this should have been 5 minus x at my starting over here at start. And this should have been 0. This 5 minus x then became 5 minus x minus
y.
2y.
Okay, 2y, yeah.
And this bugger became y. This y now corresponds to 280. And this 5 minus x minus 2y corresponds to 0.5.
Yeah.
So 5 minus x minus 2y is corresponding to 0.5 and the y is corresponding to 2. What else do I have as information available? I know that NO plus N2O3 should correspond to how much?
3:5. Wait, what?
No. NO plus N2O3 in terms of mole should correspond to how much in terms of partial pressure?
5.5 atmospheres.
5.5 minus 0.5 minus 2.
Yes. Sorry. Yes.
Correct. So partial pressure of NO and partial pressure of this should be equivalent to, should be equal to 5.5 minus 0.5 minus 2, which means this works out as 3. So this partial pressure of NO plus partial pressure of N2O3, that will in turn correspond to moles of NO plus moles of N2O3. Correct? Fair enough?
Yeah.
What am I using over here? I'm using state of matter.
Yes.
Same vessel, same temperature. Number of moles will be directly related to my pressure.
Yeah.
Partial pressure. Fair enough?
Yes, sir.
Which law am I using here? From states of matter, which law?
Wait. N is proportional to. Wait, 1 second.
Dalton's law of partial pressures.
Dalton's law.
Yeah.
Sorry. Yeah.
It's okay. There's nothing, not a problem there. Now, let's go back to where we were. So, I need to now get this to get my third equation, correct? So, let's get the third equation out. What's the third equation going to be? That's going to be number of moles of NO plus number of moles of N2O3. What's my moles of NO? 3 minus x.
Yes.
N2O3 is x.
Yeah.
What's happening then? 3 minus x plus x, they are telling me, should correspond to 3.
Yes.
Now you got your thing clicking properly now?
Yeah.
What should I do now?
Wait.
Have a look at the setup here again fully. I'm saying it's solved. I'm saying it's already done. More or less, it's just a matter of plugging things in. Why am I saying it's done?
We can.
Basically, what was the idea here? The idea was this is all moles.
Yes.
Corresponds to partial pressure.
Yeah.
That's what I was using earlier. Now, directly they are telling me from this comparison. What does this comparison give me? This comparison gives me 3 minus x plus x.
Independent.
Corresponds to 3, not independent. The equivalent is 1. They are equivalent to 1. That means number of moles is same as partial pressure.
Oh, yeah.
That's the principle now as to what I was trying to explain over here. See here, the partial pressure, it is equivalent over here. All of this is equivalent to. No, there is a third variable which I'm not including over here, which is the equivalent to variable. The correspondence variable there. The proportionality variable. You want to call it that.
Yeah.
That proportionality variable is something which we don't need to account for here. Why? Because they are clearly telling 3 in terms of moles is the same as 3 in terms of
pressure. So it'll be 1:1 corresponding.
1:1. So number of moles directly leads to partial pressure. That means I have straight away y is 2.
Yes, directly we can solve this.
That means 5 minus x
X,
minus
X
4 is
is
equal to 0.5.
0.5.
That means what is my x over here?
0.5.
0.5. So my x is 0.5 now. I am done here. How much is this guy going to be? At equilibrium. Partial pressure itself I can write now. It will be 2.5
Yes.
atmospheres. This guy will be how much?
4.5.
0.5 atm. And this
Yes,
will be
0.5.
0.5 atm. So I can straight away solve for Kp now.
Yes.
You understand the principle here?
Yes. Okay.
So when you are not clear as to what you are searching for, don't search. Find everything.
Yes, solve. Okay.
Something will click. I told you in the beginning, I didn't know what I was searching for clearly, right?
Yeah.
I had no idea what I was searching for. But you have to be open-minded enough that when you see something which will click, it has to click there.
Yeah. Got it. Yeah.
You understand the principle?
Yes, sir. Yeah.
This is a very good question. No doubt about it. This is a good question. And this is, I would say, above that previous question. In terms of JEE advanced level. This is a very good question. I am very impressed by this. They have given you very minimal information, but it is solvable. I told you in the beginning now, what I am sensing is this is either complicated and beautiful and solvable, or it is not solvable. Parents are back.
1 second.
Go for your food.
Yes, sir. Back. Oh, sorry.
You're back already.
Yeah, I did give the food.
You got your food?
Yes, sir.
Good. So you can start eating as you wish. So the idea here is this kind of a question here. The reason why I said this is either a very good question or it is incomplete is because it did look incomplete. It did look incomplete to me. When I was blindly looking at it, you can see where you're getting 3 variables over here, correct? I didn't point the 3rd variable because I expected something will click here. That's why I went with it, okay with it type of. But the fact is there was a 3rd variable. So we should have had a 3rd equation which is properly consistent. Normally what should have happened over here? We would not have had the thing cancelling off. It is still solvable even with the data. We will have to then take it as 3 variables, 3 equations and solve it.
Sir, where do you get the 3rd equation from?
Right now, we got 3 minus x plus x was corresponding to 3.
This was different. Yeah, sorry. Yes.
That would have been an equation in x. It would not have cancelled necessarily.
Then you can get the x value.
Then you will have 3 variables, 3 equations. X and y are 2 variables. What's the 3rd variable?
Okay.
The proportionality.
Yeah.
In all 3 of them. What is the proportionality going to be actually giving you? That proportionality actually gives you some information about the volume of the vessel.
Yes, moles and
that relationship it will actually give you. So another easier way in which they could have given you to solve this would have been they give you the volume of the vessel. If they give you volume of the vessel here, that would have made it a little bit more easier to solve. But it would have made it more irritating to solve. Why more irritating?
You don't know where to use it.
Calculations would have increased. And you will have extra information. So in questions of this sort, sometimes they will give you extra information also. If they give you extra information, that will just be sometimes to screw with your process, to be very honest. So this is a very good question. Definitely above the previous one. The papers are not bad, man. This is a good paper.
I guess this one.
2 questions of this level is not bad. Somebody got full in this paper?
No. Highest was 45.
Not a bad score. 2 questions are good. Not a bad score at all.
Sir, I guessed this answer. This one.
Oh, you got this right?
Yeah.
Not bad. So you had the magnanimity to actually inform that you have still not got this correct. Okay. All right. Good. That's what is necessary. Sometimes I have seen kids who assume that just because they got a question answer correct, they assume they know the shit there. So yeah, that's a very dangerous assumption to make. Good that you are not making those assumptions. Can you hear me? It seems to be getting stuck a little bit more. You're eating consistently. Okay, all right. Let's get to the next one.
No,
what were the other questions? Any other really interesting questions? Because we are already overshooting.
I don't think anything else.
Remaining are all easy questions, is it?
Oh, so that PQRS thing is there, right?
I'll just quickly blast through each of them. This 34, P and S established 2 equilibria in a closed vessel at 300 Kelvin. KC1 is given. Oh, this is solid. Oh, this is good. Yeah, this is good. Is this also from the tough paper?
Yes, sir. Yeah.
Okay, huh. Okay, P and S established two equilibrium in a closed vessel. This is not as good as the other two, but it's different variety. You already know how to solve this, or you're still having issues?
So I know the first step, but then I mean
Okay,
I know the
that's
rough
okay.
idea, but
Okay,
then
so let me quickly process it out. So P solid is in equilibrium with Q gas and R gas. KC1 is not given over here. R gas plus S gas is going to be giving T gas. KC2 is not complicated. It's an easy question only. 10 power 8. What does 10 power 8 tell you?
completely dissociates.
Hmm?
Completely dissociates.
Completely moves in the forward. Okay.
Yeah.
Till what?
Till reactants tend to 0.
Till any one reactant tends.
Limiting. Yes.
That is where this question is going to be leading to. Okay. So the real crux of this question is going to be to find out which one tends to 0.
Okay.
You understand the principle over here?
Yes,
Let's
sir.
start off. So in this case here, let's go with the actual equilibrium here. This guy. So R gas plus S gas is going to be giving me T gas. Okay. P solid, Q and R are obtained over here. Okay. P and S solid. What the hell? What the hell? These idiots are, what are they doing here?
That's what said. Yeah.
Fools. Shitty question, I think. Let me see if it is solvable again, or if there is some data missing, because I have a sense that it is probably missing this equation. Mostly that is missing this.
So I think it's just a typo, I guess.
So I will look at the question fully now. Let's see. Q gas and S gas are at equilibrium. Okay, now if this and this are this and this, okay. KC1 will be A into 10 power. Oh, this is not that complicated. It's doable only. Okay, all right. So let's continue on. So we're going to be having Q gas and S gas at equilibrium are 2 into 10 power minus 2 and 10 power minus 5. So Q and S they have given. So this and this they have given. And they are giving us this value. Okay, all right. 10 power minus 5 is S gas. Okay, this is 10 power 8. Frustrating. Frustrating. So this is 10 power minus 5. Equilibrium constant. This guy is some variable again. So P solid is going to be in equilibrium with Q gas plus R gas. Okay. R gas, let's say I'm taking it as X over here. Let's take this guy as Y. This guy is given as 2 into 10 power minus 2. And this is given as some A into 10 power minus 7. Beautiful fellows. And the A here is an integer, correct? Numerical? Aman?
Yes, sir. Yeah. Yes,
The
sir.
A here, what is that? Integer, numerical?
Yeah.
0 to 10, what is it?
0 to 10.
Huh? Supposed to be 0
4,
to 10?
Yes, sir.
Supposed to be 0 to 10, correct?
Yes.
Okay. You're sure that is the thing which was given in the questions?
Yes, sir. Yes.
Okay.
OMR had 0 to 10.
Then it makes our job easier. So that is actually a data point in itself. So this is some 10 power minus 7 into some value Z, or rather A. Okay. All right. So now in this particular case, that means this is going very tiny bit in the forward direction over here. And this has to be 10 power minus 7. That means my R here has to be something which is obviously extremely tiny here. So in this particular case here, it is going to be A into 10 power minus 7 divided by 2 into 10 power minus 2. So A into 10 power minus 7 divided by 2 into 10 power minus 2. Now I will have this as 10 power minus 5. And this is 0.5A. So my X works out as 0.5A into 10 power minus 5. Okay. So let me put this over here. So this is 0.5A into 10 power minus 5. Okay. So this guy is Y and this bugger is supposed to be 10 power 8. So this fellow is supposed to get a 10 power 8. What will this work out as? This will work out as some Y Okay, so 0.5 a and 10 power minus 5, and this is 10 power minus 5 at equilibrium. At equilibrium. So the R also is at equilibrium there. So that is the leftover at equilibrium. These two are the amounts at equilibrium here. Okay, all right. So I can get Y in terms of A as well. Then. Fair enough. That is easiest. So Y divided by 10 power minus 5 into 10 power minus 5.
2 goes up.
2 over here in the numerator divided by A here
Is equal to 10 power minus 8. 10 power 8. Sorry.
is equal to 10 to the power of 8. So I'm going to be having this burger going to become 10 power minus 2 here. So I will have Y being equal to A into 0.5 into 10 power minus 2. Okay. So where are we stuck now at? We are stuck at a situation where we are having A still variable and everything fits into the pieces here. Let me put them all together and see if it is still stuck. So we have P solid in equilibrium with Q gas plus R gas. And we have what here? We have this as 2 into 10 power minus 2 at equilibrium. Huh? Okay. So this is 2 into 10 power minus 2. And R was 0.5A into 10 power minus 5. 0.5A into 10 power minus 5. Okay. All right. And we are going to be having this over here as R gas plus S gas is equal to P gas. And we are having R gas was 0.5A into 10 power minus 5. And S gas was bluntly given as 10 power minus 5. And the T worked out as 0.5A into 10 power minus 2. And we're going to be having 0.5A, 0.5A going off. This will work out perfectly in the 10 power 8. So this is inconsistent. We do not have enough data. We do not have data.
The solution, 1 second. Check with the solution.
Message me that thing. You've messaged that already?
1 second. I'll have to send it.
Not this question, dude.
Hello?
You sent me a wrong question solution, dude.
Oh.
This is the one we just discussed. This 30.
Oh, sorry. I don't know. My bad. 1 second. I sent the wrong one.
33 was fine.
Yeah, here it is. Sir, what they did was they added the equation and they did something.
In 34 order?
Yes, sir. The question we're doing right now. Yeah. Yeah, isn't it, sir? They added it in like the KP will be, sir, KC will be very high, so something like that.
No, the problem is it will not be now.
It depends on KC.
Add the equations. What are you supposed to be getting? You're supposed to be getting KC1 into KC2.
Yeah, so A into 10.
10 power minus 7, that's 10
10A.
power 8. Where is it very high? It is not very high. It is not to be added. That's wrong. Let me have a look anyway. You sent, I suppose, no?
Yeah, I sent it, sir.
Where is this 2 into 10 power minus 2 given? T gas.
So that's what they did, sir. Since it's completely dissociating, they took T as 2 into 10 power minus 2.
No. That's not correct.
That's what.
That's an assumption which is wrong, Nuri. That's not correct.
Yeah, I don't understand what they're doing.
That's not a fair assumption. Let me copy it off fully and then show you why I'm saying it's not a fair assumption here. Let's directly place it in where what we are discussing. You'll understand quickly then. Let me remove some of these other things. All right, so what did we arrive at over there? We got this, no? So this is what was the last thing which I had arrived at over there. So in this particularly here, if you're blindly assuming this is going to be, what to say, 2 into 10 power minus 2. If you're blindly assuming this is 2 into 10 power minus 2 here, then
Yes.
straight away we're going to be having 0.5 into a here being equal to 2.
Hmm.
Which means a straight away works out as 4.
Yes.
Which is
That's
probably
the
what's
answer.
the answer over here.
Yeah.
It's a very, very shitty way of doing it. That's not correct. That's not correct. Why is that not correct? Because as you can have a look over here, this is not going to full completion. Because the amount of the R fellow left over here is both very low. That is the reason why the equilibrium constant is looking high. And they've given you this is 10 power minus 5 here. This is also very low quantity. It is not going to be, this is a very bad approximation. This is what is an extremely poor approximation, because in this particular case here, actually, let's assume it is an acceptable approximation. Let's see if it is acceptable. Let's back calculate and see what happens. If I end up taking this as 4 over here, I'm going to be having the entire thing solving off comfortably. All right. Now, let's see if it can be some other number. That's where things will basically be more interesting. So, can I take A as, say, 8? If I take it as 8, what happens here? Let's check the numbers overall. This will become how much here?
4.
4 into 10 power minus 5. So the way to check if whether what they have done is correct or not here, this is a very unfortunate circumstance where I'm checking. So I have to check by putting numbers to see, because I've got a generalized solution. I've not got a specific solution. And I'm telling that this generalized solution is the way to go about it. So if I have to check if the generalized solution is more correct, I'll have to plug other values and see if it can match up.
Hmm.
So in this here, let's say I'm plugging in A as 8. If I plug in A as 8, I'll get this 4 into 10 power minus 5. This fellow will also work out as 4 into 10 power minus 5. This fellow will work out as 4 into 10 power minus 2. In that particular case here, let's have a look at whether things work out properly. What was the K? What is the 10 power 8 should be the equilibrium constant here. And this should be A into 10 power minus 7. A is 8. Correct? So here it should be 8. 8 into 10 power minus 7. That's the idea. So let's see if they match up properly. So it's 4 into 2, 8. 8 into 10 power minus 7. Fine. 4 into 10 power minus 2. 10 power minus 5. 10 power minus 5. 10 power 10. 10 power 8 aa jayega. 4 and 4 will cancel. It works out perfectly. That means in this particular case here, their solution is not proper. Definitely not proper. It is based on a very bad assumption there. And if you're given a, I will be blunt and honest with you over here. Shamelessly, if you're given this in a JEE advanced paper, make the assumption. It's not a bad one to make here. But you have to be very clear what's happened though. Because the fact here is, if you make the assumption, because the assumption is the correct way, and you think of it as correct in your brain, then you're wrong. Then you are making a very bad, you're planting a false flag in your brain, a false assumption in your brain. So avoid doing that. So for this question here, my conclusion here is this question is wrong. It needs more data. And for solving this, you will need one more bit of data which is necessary, which is going to be this. Mostly. If you're able to get that equilibrium constant over there or some information about that, then it is more doable. But if you're only given this as the question over here, go with what your teacher has done there. Go with that analysis over there. Blindly make an assumption. But remember, That assumption is wrong.
Wrong.
Remember clearly, that assumption is wrong. That assumption is going to be something which you're going to use purely because you have arrived at the fact that this question is inconsistent as of now, but you need to put an answer. You understand the idea here? You need to put an answer. Why should you
Yes,
put an answer? Because you are not supposed to leave a question of this sort empty.
Yeah.
You have to attempt it. But if it is something which you can throw away in choice, do it.
Yeah. Numerical
That's what I mean by throw away in choice, right?
Yes, yes.
If that option is available, you should. If that option is not available, go with what your teacher has done here. It is not the correct answer, but no, it is not the correct answer, but do it. Because that is the best chance of you getting marks.
Mm.
And ultimately, that's the path you must follow. That's the path which brings you maximum benefit. You should follow that. So that is my conclusion for this question over here. Any other question which I need to pay attention to and watch for carefully, because it's getting longer and longer, the session. This is a good paper. You had a good paper here and some fairly good questions. 22 was something which I wanted to see also. What did you screw up over here for 22?
Sir, I put KP changes, but alpha does not change.
Consider the following equilibrium in a closed container at a fixed temperature. At a fixed temperature.
Yeah. So KP won't change.
Gas.
Yeah, my bad.
Okay. The volume of the reaction container is half for this change, which is the following K. Okay. Degree of dissociation might change, but KP will not change.
Yeah. Yes, I know. I realize.
Depends on what to say.
Fresh. Delta Ng.
Delta Ng, correct. If I'm going to be having delta Ng being 0, even degree of dissociation won't change.
Nothing will change. Yes.
That's the idea there.
Yes,
let's quickly have a look at the remaining questions here. In this here, which ones were your issues here? The delta G naught, you said they have only given you a formula for now and blindly use the formula, correct?
I put R value as 1/12 instead of 8.31.
KP or K equilibrium? What did they give you?
Sir, 2.3. Yeah. K equilibrium.
K equilibrium. Okay, all right. So in this here, there are a couple of points to pay attention to. This is going to be in KP if only gases.
Okay.
Or any gas, actually. If any gas in equilibrium. And this will be KC if no gases. You understand what I'm saying here?
Yes.
There's an important thing which you need to pay attention to when you're using this equation. They would not have bothered mentioning it at this stage. Or did they mention it?
No, sir, they didn't mention.
Okay, all right. So blindly sub it over there, get it done. R value, you made a mess, is it?
Yes, sir. Yeah. I didn't know where to type 8.314.
You didn't know value of R as 8.314?
No, I thought we had to take 1/12, 0.0821.
What crap? So you don't know R's units then?
I mean, I directly
R's
used to use
units are 0.0821 liter atmosphere
liter
per
atmosphere per mole. Yeah.
8.314 joules per Kelvin mole.
Yes. Yeah.
And 2 calories per Kelvin mole. All the units you need to know. No goddamn escape for R. What is wrong with you? R is one of the most important significant constants in both chemistry and physics.
Yeah.
And in this one, what did you screw up here? What happened here? Stoichiometry. Okay.
So I was getting.
That is not a convincing answer, but I do not have time and the patience to go through it right now. I'll have to shut up now because I might have another class soon enough. So I think it's already close to 1.5 2 hours plus. Kitna ho gaya? 1.5 to ho gaya na?
Yeah, 2, I guess.
So
touching 2.
It doesn't matter how much. 1.5 is what I committed for with Himatej. So yeah, that is done. So yeah, all right. I will shut up now. Then we will catch up in the next session where I do want a more clearer analysis as to what went on. And organically, what is happening now? Have they started it or they have not started it yet?
No, sir. Just like basic. What is organic?
And solubility product, were there any issues for you? You understood that properly?
Yes, sir. Yeah.
So ionic is cleaned out then properly.
Yes.
Parts which are still issues in ionic?
No, sir. I don't think so. No.
We'll have a look at ionic again once in the next session anyway. So yeah, I will see you in the next class too. Bye-bye.
Yeah. Thank you, sir. Good. Sir. Bye.